The team later identified several other Kuiper Belt objects. They calculated there must be billions orbiting the sun in a vast disk. It was our first proof that our solar system had giant surprises in store for us, way, way, way beyond where we thought the solar system ended.
The discovery of the first Kuiper Belt object was a fantastic achievement. It was observational proof that there was an entire population of objects out in the solar system that we thought might exist and then found out truly did. It would be as big as discovering another full-fledged planet.
The Kuiper Belt is vast. It extends 50 times farther away from the sun than the orbit of Earth, and dates back to the early days of the solar system.
The material in the Kuiper Belt really is leftover building blocks of the planets. This stuff should have formed into larger planets like the Earth or Jupiter, but some of it actually got thrown out. And it stayed that way, small little chunks of stuff, remnants from the formation of the planets.
The discovery of the Kuiper Belt instantly inflated the size of the solar system, but deflated the status of one member. Because some of the objects in the belt were bigger than our smallest planet, Pluto was demoted to dwarf planet.
I have actually really enjoyed the controversy about what do you call Pluto? Is it a planet? Is it a dwarf planet? Is it something in between? It shows people still care. Pluto is still fascinating, it's still an important part of our solar system, but now we see it in the context of its nearest neighbors.
Let's not get angry that Pluto's no longer labeled a planet. Let's get interested in the fact that Pluto is a dwarf planet and can teach us lots of things about all of its new friends that we're discovering year after year after year.
Pluto now has over 1,400 brothers and sisters, called Plutinos.
If Pluto's a planet, all the Plutinos are too. So I have a daughter. It would be very painful for her to try to remember all those names.
The discovery of the Kuiper Belt opened up the solar system, but it was only the start of our journey of exploration to the outer reaches.
The Kuiper Belt, it's huge. But if you think the edge of the Kuiper Belt is the edge of the solar system, you're thinking way too small.
Way beyond the Kuiper Belt, the sun has actually deployed a deflector shield around the solar system. Our star is waging a cosmic war against the biggest guns in the galaxy, and our lives depend on it winning. For a long time, we assumed the solar system ended where the planets ended. But the discovery of the Kuiper Belt in the 90s doubled the reach of the sun's influence and led scientists to ask, could it reach further? Turns out it does, much further. And we wouldn't be here if it didn't.
If you put a Geiger counter in this room, it would click. If you put a Geiger counter up in space, it would click a lot more.
It's detecting a deadly form of radiation called cosmic rays.
Cosmic rays are essentially subatomic particles like the nuclei of helium atoms and protons and electrons that are zipping through space at almost the speed of light. And these can travel across great distances, hundreds, thousands of light years. And it turns out they hit us here on Earth.
Cosmic rays blast out of exploding stars deep in the galaxy, and they're incompatible with life.
They can rip out electrons. They can, in fact, change the chemical configuration of cells, causing mutations. They can ultimately kill you. If the Earth were continually blasted by cosmic rays without any protection, it's not clear that advanced forms of life could survive.
But very few of the cosmic rays aimed at us hit us. Clearly, something out there is protecting us from the full onslaught of cosmic rays from the universe. It's our sun, creating a deflector shield reaching 8.7 billion miles out in space, using its solar wind.
When you think of wind, you think of the air of the earth, moving through your hair. The solar wind is nothing like that. It is actually a stream of high-energy particles coming off the sun, things like hydrogen.
And it's substantial. It's billions of tons every second.
Some parts of the solar wind are going as fast as about 2 million miles an hour. It can pack quite a wallop.
The wallop blows by us here on Earth because our planet's magnetic field deflects it away.
The solar wind doesn't just stop at the Earth, it's out in space. It keeps going. It blows past the inner planets. It blows past the outer planets, Jupiter, Saturn, Uranus, and Neptune, and keeps going.
It also blows past the Kuiper Belt, carrying the sun's magnetic field 3.5 billion miles beyond, and creates a huge defensive shield around the solar system called the heliosphere.
The solar wind is blowing a bubble around our solar system.
The sun is like a big mother that literally creates a bubble of charged particles and associated magnetic fields that protect us from cosmic rays coming from outside the solar system.
The incoming cosmic rays hit the outgoing solar wind, and most are deflected away into space. Without this standoff deep in space, we'd be wiped out.
Like everything else in nature, the solar wind is kind of a two-edged sword. It can harm us here on Earth, but it also protects us from this galactic material.
There are so many instances in the universe where something that you think at first would be very dangerous and destructive can even be protective. And the solar wind is one such thing. Yes, there are these high-energy particles coming from the sun, but the effect of the solar wind is to protect our entire solar system from even more dangerous kinds of particles.
The protective bubble battles its way through the dust and gas as the solar system slowly orbits the center of the galaxy.
It's plowing through it like a boat moving through water, and there's a wave where the solar wind has slowed to a stop as it's slamming into the material outside of the solar system, into interstellar space.
And it was here that NASA's Interstellar Boundary Explorer, or IBEX, found a completely strange and unexpected phenomenon.
The IBEX mission actually found a giant streamer of hydrogen gas, the largest thing we've ever seen in our solar system. And this may be due to the interaction of our solar system's magnetic field with the larger magnetic field of the galaxy.
Scientists think that the interaction between the sun's solar wind racing out and the interstellar medium of the galaxy pushing in traps the particles into a giant ribbon. The ribbon is nearly 100 billion miles long, making it the biggest object in our solar system.
It's fundamentally so exciting to learn about these extended structures at the edge of the solar system, because quite frankly, no one expected this. No one ordered this. And so by seeing things that we weren't expecting before, that's how we really learn, and that's how science progresses.
IBEX and its 21st century technology are telling us stunning new things about our solar system. But it's a never-say-die old clunker from the 1970s that's sending back the most exciting news from the outer limits. After traveling for almost 40 years, the Voyager spacecraft is still sending us messages about bizarre fields of huge magnetic bubbles and giant high-powered jets blasting out from our solar system.